we're going to go ahead. Once again, thank you so much for being here. This is our third workshop series, our third workshop within this series of ArcGIS Online. So this is working with your own spatial data, taught by me. So for those of you that did not come the last couple of times, just to give you a little bit of an introduction about myself, I have a background in forestry. That's what I got my undergrad in, and that's how I got into GIS. GIS is used a lot in natural resource management. So that's my perspective on it. I know that most people I work with on campus are human geographers or infrastructure geographers, and that's a whole different ballgame. But that just goes to show you how versatile the software is. So now I'm getting my master's in geography here at UMass. That's what brought me here. And I'm also the library teaching assistant, which is why I'm teaching this workshop. And also I've been using GIS since 2017. Makes me feel a little bit old. And the software has come a long, long way since 2017. It was so clunky back then, and especially ArcGIS Online was not at all what it used to be. So for today, this is the agenda that I have planned. We're going to go over some projections and data types, where to find open source data. In the last class, I chatted a little bit about how you can find data on ArcGIS Online. And for those of you who didn't attend the last class, the last two classes, I welcome you to go ahead and look those up on our library's webpage. Let me post the link to all of our tutorials in the chat. There you go. Especially the last workshop was had a lot of great resources about that. We're going to go over how to import data in AGOL. I will warn you that, again, my internet was super slow. So when I was trying this for my office earlier today, I wasn't the most successful. So we're going to cross our fingers and hope that it plays nice and that it doesn't freeze up on us. We are going to experiment with creating our own data, some data analysis, and I left a little bit of time for troubleshooting at the end, especially since a couple of people have come to me during my office hours to ask about this kind of stuff. So if you brought your data along with you, we will have time for questions at the end to troubleshoot any issues that you might be having. So before we get into all of that, let's go over projections. For the non-geographers in the room, a projection is basically how we display the globe, the roundness of the Earth on a flat surface, because maps and computers are flat. So that means that we have to take the globe and kind of flatten it out and stretch it in different ways. And there are a lot of different projections. The most common type that you might encounter is NAD 83 state plane. A lot of the Massachusetts data, especially from MassGIS, is published in that projection. And so if you're working with smaller data sets like that, typically you will be working on the state level. However, when you publish anything to ArcGIS Online, it reprojects it on the fly to WGS 84 Web Mercator. And that is not the most accurate projection. It tends to have like quite a bit of error. I think the error margin is, I wrote it down, it's 20 kilometers. It's up to 20 kilometers on the ground. So if you're collecting your own data, definitely don't use that. But ArcGIS uses that because it was made by Google initially, and it was specifically created to allow for infinite scrolling. So if you're ever like on Google Maps and you can scroll forever, or Google Earth, this is the projection that allows us to do that. So it's kind of universally adapted by online platforms. And it is made for web maps specifically. Next, before we get into the actual ArcGIS Online bit, we're going to go over data types. So there are three kind of main data types that you might be working with as a beginner ArcGIS Online user. The first is a CSV. We're all familiar with that, right? It's another version of an Excel product. A lot of you who might be collecting your own data might just be storing it in latitude and longitude coordinates. And so today we're going to go over how we can convert those latitude and longitude coordinates to actual points on the map. The second data type is shapefiles that uses the extension SHP. Shapefiles are what you would get from online data sources if you are downloading, like one of the data sets that we'll be working with is towns from Massachusetts. And so that'll come as a shapefile. And the important thing about that is that it's never just a shapefile. It has a lot of other data that comes along with it. But I will also tell you a little bit more about that later. And then the last data type is .tiff, and that is for raster data sets. So we didn't talk about this kind last time, but raster data sets are typically used for imagery when you are working with like land cover data. Anything that's derived from land cover data, like digital elevation models, and oh, what else? And digitization. So if you have any old historic maps that have been georeferenced, then those will also be in the TIFF format because they're images. So TIFF is for pixels, anything having to do with pixels. Lastly,
Can I just ask, are you meaning to share your screen right now?
Yes. Oh my gosh. Am I not sharing my screen, you guys?
Not yet.
Oh my gosh, thank you so much for letting me know. I appreciate that. Sorry about that. Um, these are the fun graphics that I was intending on showing you while I was talking at you. See, this is a lot easier when I have a co-pilot. I'm a little bit nervous because I don't have my co-pilot today. So anyway, this is how you stretch the Earth onto the WGS 84 Web Mercator projection. For visual reference, these are the data types. As you can see, we have the CSV with the latitude and longitude. Shapefiles will represent points, lines, and polygons. And that is, you know, buildings and roads and counties and towns. And then raster, as you can see, is the pixel format. All right, lastly, please screenshot this if you are able to. I can vouch for the first three sources. The rest are just sources that I've heard have really good open source data. But as we covered in the last class, AGOL and Living Atlas are great places to find open source data that you can work with that'll help you run your analysis or visualize whatever you need to visualize. And then I'd love to show you guys MassGIS and the national map. So MassGIS is this great website. Assuming that most of us are going to be working with Massachusetts data, the website has a lot of different types of downloadable data on there. Everything from census and demographic data. Somebody just came to my office hours today asking about how to retrieve and how to work with census and demographic data and tie it to a spatial location. So there's coastal marine features, environmental monitoring, infrastructure. Everything is published through the state, and Massachusetts is way better than a lot of other states in terms of what they provide, because as you can see, they have a lot of different layers on here. So definitely check that out, especially if you need anything like towns. We'll be working with towns today. And then the second best resource that I personally find for you working with working with open source data is USGS's The National Map. So this is a USGS product. This is really helpful if anybody here is in the historian world. They have a lot of historical topographic maps. I don't know if you guys know this. USGS produced topographic maps for years. I mean, I bet they still do. But they have this really large repository of historical topographic maps. And then they also have the elevation models and imagery and other things that might not be the most relevant. But this one I really like for boundaries. If you are working anywhere outside of Massachusetts, definitely check that out for your data needs. So I saw a question come up in the chat. Let me see that. Yes. Okay, great. So let's get into it. My internet today is really just not working with me. We'll get through it. So if you want to follow along with this, please sign in. Some of it will be applicable. If you are working with your own data, we can troubleshoot anything that comes up, but I think you'll be able to kind of get it if you're working on uploading your own data. So as always, please go to arcgis.com. If you are working through the UMass organization, we are going to log in through this function right here, type in UMass-Amherst, and it remembers all of my login information. So it's logging me in automatically, and somebody's about to disturb my office time. Once we are here, just like last time, we are going to click on map. Hey guys, I'm in the middle of a workshop, just letting you know. So we are going to open up a new map. And the first thing that I would love to show you is how to work and upload with data from a CSV. So I created the CSV of all 5 of the UMass campuses, and I got their lat and long coordinates. And I just did that super easily through Google Maps. If you look up anything and right-click on a location, Google Maps will show you the lat long coordinates. So this is the data set that I'm working with. Let's add it to our map. So we don't have anything in the layers right now. You can add data through here or through here. Either one's fine. We're going to add our data as a layer from a file. So I am going to drag and drop my layer from my desktop folder. Here it is. And I find this to be super helpful because I think let's try to do it a couple of different ways. If you drag and drop, it will just create a hosted feature layer. If you do it through the add it through your devices bit, and I will find it on my desktop, and oh, it still does it the same way. Sorry, this went a little bit differently the other day. So once you click create your hosted feature layer, it'll ask you to identify the different fields and the display name and type. You generally don't really have to worry about this. ArcGIS Online does a pretty good job of choosing the data type for you based off of what the what the cells contain. So the default looks pretty great to me. We're going to click next. It is identifying that there's latitude and longitude coordinates just based off of the fact that I have two columns named lat and long. So everything looks good here. There are also, there is an option to do this with addresses if you don't have latitude and longitude coordinates. However, keep in mind that that uses credits. So as we chatted about in the last workshop, every UMass ArcGIS Online user gets, I believe, 100,000 credits. Don't quote me on that, but I'm pretty sure that's how much is allotted to every person. And you can reach out to administrators if you need to use more than that. But in general, it's not an unlimited resource. So if you do need to geocode, there are a few free geocoding services, but the best one is going to be through Texas A&M. And I'm going to drop that link in the chat. So they provide a free geocoding service where you can put in your table with addresses, and then it will convert it to latitude and longitude coordinates for you. So you don't have to use up all of your AGOL credits. Lastly, if you are just adding a standalone table, you can click none, and that will add in your table just as a table. But we're working with lat longs, so we'll click next on that. This is remembering my data from earlier, so we're just going to call it UMass Campuses 2 because it needs to have a unique name. And I won't worry about the tags in the summary for now. We'll just create our item. Okay, fantastic. Because I didn't delete this from earlier, this already exists in my account. So we'll just add it from my content. All right. So this is my UMass Campuses layer. It has been added. I can see it in the layers tab here, and it shows this as a default symbology. If you want to change the symbology, refer back to workshop number 2 for how to do all of that. But let's take a look at what our table contains. So we'll right click on these 3 little dots, show our table. And here we can see all of our locations and our attributes, which are the lat and long coordinates. So that is how to upload data from a point source. If you are working with a shapefile, if you happen to download a shapefile from one of these websites, one of these open source websites, or if you just want to include some of this data for visualization purposes, we can go ahead and do that as well. Sorry, guys, give me 1 second. Does anybody have any questions so far while I'm configuring my contents over here?
Hi, Deni. Yes, I do have a question. So wondering if there's any way for those points to display the campus name. Like if you wanted to label the points as Boston, Lowell, Dartmouth, is there a way to show the labels?
Yes, for sure. So there is a labels option here where we can make them label. You see how it has the label over here. But I also cover that a little bit more in depth in the second workshop. So that'll be the theme of this, is refer to the second workshop for how to symbolize the data. But thank you for your question. So I have uploaded the mass zips shapefile as a hosted feature layer. We are going to try to do this together. But again, things were being very slow. So let's try to do this all together now. I was really curious about displaying data, displaying my campus data in combination with the Massachusetts towns. So from MassGIS, I obtained this data. I went to the infrastructure tab, and was it the infrastructure tab? It was the political and administrative boundaries. So I'm working with this zip code data that you guys are welcome to download from here. And when I'm adding my data, I'm going to add it from a file, and I'm going to click on my device. For people that have worked with geospatial data before, I will let you know that when you download data from open source websites like this, and when you are working with shapefiles, typically you will see the shapefile will come to you as a zipped folder with a lot of other file extensions. So the shapefile itself is the .shp extension, but it comes with a lot of extras that you definitely didn't ask for. So those are oh gosh, sorry you guys, I'm a little bit off today. So this is what it will look like typically when you download a shapefile from open source. It'll come as a zipped folder with all of these extra files. So the common terminology is your shapefile, which is this. The extension is .shp. And a common mistake that I see a lot of people making is when they're sharing their data, they only send the SHP. But it's really important for you to know that all of these files are relevant, not just the SHP, because the SHP file stores the geometry data itself, but then all of these extra ones also have really important data. And if you try to work with only the SHP, you will likely encounter a lot of issues with your data, like some of your contents might be missing, your attribute table might totally be missing. So it's really important to have the rest of these, like the metadata. These two files are index files. This is the database file. The PRJ is your projection, so that's also super important. And this is code page. And so keep that in mind, that when you are sharing data with other people through email or whatever your platform is outside of AGOL, send the whole folder with everything in it. So ArcGIS Online also doesn't take only SHP files when you're uploading your shapefiles. So I'm not going to drag and drop it. In this case, I'm just going to select the compressed zip folder, and it will do its magic for me. So I've selected it. It has correctly identified it as a shapefile with the option for me to change it to a file geodatabase, because one of those files is a geodatabase file. But we will stick with shapefile because it's correct. We're going to click next. We're going to hope that this works if I add a 2 here. And I won't worry about tags or summary once again. And we will try to upload our data. Okay, fantastic. Because the zip file is in there, that's what I thought. That one I did delete. but we're gonna try to add it from my contents. So this is the zip codes file. We're gonna add that to our data, and it shows up again in our layers tab. Now, I'm not going to totally go over symbology, but this is a little bit abrasive. So I am just going to maybe make it a little bit more transparent, not less. There we go. That works. That's a little bit better. So we have our point and our polygon layers on there. Next, we are going to learn how to create our own data. So we went over uploading CSV files. We went over uploading shape files. And let's try to create our own data. So for this, we are going to go to our content pane from here. Because unfortunately, you can't create your own brand new layer. In the map view, you have to do it through the content pane. So we're going to click on new item from here. I'm interested in also this is all the different things that you can create within your content pane, but we're interested in creating a feature layer. So we'll click that. I am going to define my own layer. Using a template and ArcGIS server is a little bit complicated, so we'll just define our own layer for today. We'll give it a point, or sorry, we'll give it a name. That sounds good to me. And one very funky, interesting thing that ArcGIS Online does that ArcGIS Pro doesn't do is you can add in multiple layers within your feature layer. So we can call this one point. We can also do a line layer and a polygon layer. So let's configure that to its correct data types. We're not going to worry about the extra options. We'll keep it simple. Next. And once again, when you are creating your own data, remember to give it meaningful titles, meaningful summaries if you are going to be sharing it with the rest of your organization and other people in general. This is just a demo, and this is not getting shared anywhere, so I won't be worrying about that. But I do recommend doing that if you are working with other people. Do I have any questions so far? No, okay, so my layer is created. Let's add it to our map. We're gonna go add layer. From my content, I can see that it's present here now, and I'm going to add it to my map. So if I go back to the layers pane, you can see that this one looks a little bit different than the other two. There's this drop-down menu, and it'll show me the 3 layers within the layer, which is a little bit confusing. But right now, there's nothing on there. Even if I turn the other 2 layers off, you can see that there isn't anything on there. So let's add some data. And we're going to do that by editing our layer. So if I click edit here, it already knows the point data set has options for adding points. We can add lines, polygons, and these are disabled because they're turned off. So let's add a few points, and this isn't anything specific. But 4 points, you are just going to click around, and as soon as you click somewhere, it will create a new point for you. Click create. And then we can just do that and create as many points as we want. I don't recommend doing this manually for many purposes. It's a lot easier to just have a CSV with your lat and long coordinates and do it that way. We're going to finish creating that point before we go back. So now let's add some lines to our data set. Let's say that I want to add in the Route 9 from Hadley to Amherst. So I'm going to start in Hadley. As soon as you click somewhere, it'll start your line and you can go anywhere with it, and you can have as many little nodes as you want. So I'm just going to click along this road. I'm not doing a very great job of keeping this straight. And then as soon as you want to finish creating your line, you're going to double click. And there we go, that we have our feature. We're going to create that. And that's it. If we want to add more, we can do the same thing. All right, create that. And that is our line feature layer. Next, we're going to try to do some polygons. Maybe we'll do the field from UMass. And just like the line feature layer, you're going to click to start creating your polygon, and then keep clicking along the extent of where you want it to be. And you can get some funky like negative like crossover with that. So just be careful to not do that. And if you do have overlapping polygons, just create 2. And then to end it, we'll double click, and that is our polygon. Now, let's say that I wasn't super happy with this, and I was like, oh my God, I should have included this little sliver of the road. After I create it, we are going to edit our feature. So to edit our features, we're going to select one and click on the actual feature once the bounding box comes up, and you can move each one of your little vertice points around to get it absolutely perfect however you want it, and update that. And we have that. And we can do the same thing with our lines. If I'm like, oh my God, this line, not long enough, let's select it and continue to edit it. So that it's actually a little bit more along the line. And we'll click update, and that's saved. So that is how we edit our own data. The last couple of things that I want to show you is how to upload raster data. That one is a little bit trickier. That's the part that makes me nervous because it was absolutely not working when I was doing this earlier. But let's try it together. So the file that I have is going to be, let me rename it really quick so we don't come across the same issue as before. If it will let me. Okay, so for creating a raster file, I am going to Oh my gosh. I'm gonna do this through my contents pane because I find it a little bit easier to work through here if we're creating a new item. So we're gonna create a new item, scroll down to an imagery layer. There's also a raster function template, but that is more for like land cover and raster data that involves more than just pixel values. So the data set that I'm going to be working with today is this fire insurance map that I just got from the library at UMass. I think they have 5 of these historic maps that have been digitized and georeferenced. And so when it comes to this kind of raster layer, these are just going to come up as pixel values of the color. It doesn't represent anything like a digital elevation. So we're going to create an image layer. It's an image. We don't have to worry about doing anything fancy like dynamic imagery. We're going to keep it simple, do a tiled image layer. This is just the one image. And I am going to, once again, browse through my downloads. This is the referenced image. And we're going to wait for that to upload. I'm glad that it's playing nice. So once that is finished uploading, we'll click next. I can give this a more meaningful title, like the fire insurance map of Holyoke, because that is what it represents. We'll create that. And this is the part that usually takes a minute to do. I'm crossing my fingers. All right, I'm going to assume that it's not going to play nice because it wasn't earlier. So I'm going to give up on this. Oh, it's like it's listening to me. I'm going to give up on this and just tell you that it's already in my contents pane. So if I want to add it, oh, did it finish? We'll try it. We'll try it. Worst case scenario is it can tell me that it's not going to happen. All right, well, this is a great lesson to demonstrate to you guys that one of the things that you will encounter in your GIS journey is that GIS software often breaks for no good reason. Sometimes, like today, it's most likely my internet. I am in the office. But for one reason or another, data gets corrupted all the time. Sometimes your map just doesn't want to load, doesn't even want to load the base map. Things like that happen. So general rule of thumb, save your data and save it often. And
It looks like
have,
it's loaded on the tabs.
yeah, here I did notice that it's loaded. It should come up here, but we can try that again. I'm more concerned about how my map isn't showing up. But in this case, when this happens, I recommend saving your map. So let's save it. Workshop number 3, map, meaningful enough name. And I just want to go ahead and do that so that when I refresh the page, because as a general cure for all of your GIS issues, when it's not working and it's not making sense for why it's not working, turn it on and off again. And I have been saying this since 2017, and it has about an 80% success rate for turning it on and off again. Usually it's not you, and you can't take it personally. So we're gonna save it and really hope that it works. So that I can show you one more fantastic thing that I had planned for this, which is the analysis portion of the workshop. In the meantime, does anybody have any questions about working with their own data? I know a handful of you are interested in working with your own data through ArcGIS Online. Can I answer any questions? I apologize, you guys. This was not part of the plan for this workshop. I'm gonna try just refreshing it so that we can carry on. And let's try to add this again. Awesome. So this is what a great example of what a georeference map will look like. If you find one online that you are curious for using just for mapping visualization purposes, it should show up georeferenced and scaled correctly. And if we kind of turn the transparency up, maybe we'll zoom in kind of over here, you can tell that the canal specifically lines up perfectly with where the canal is on the base map. However, if you're interested in, let's say, creating your own layers from a georeferenced historical map, this is also a great way to do that. As I mentioned with our last layers, if we add those in and we say, okay, one of these part of this data set is going to be the roads in Holyoke, we can edit our layer to show more of the roads in Holyoke and do it visually. And that is how back in the day when the software was first getting created, this was really big. And I have had a job that included a lot of digitizing and things like that. And if you find yourself working in GIS, this might end up being something that you might want to do. So that's the raster portion of the workshop. Last part that I wanted to show you guys is the analysis. So let me exit out of here. We're going to turn this off. I'm going to bring in our zip codes layer again and our UMass campuses for this. We'll turn these off. So I have my 5 UMass campuses and my zip codes layer. ArcGIS Online has a small suite of tools that you can do kind of basic analysis on. If you find yourself needing more tools than this, more for visualization, more for analysis, I would recommend moving on over to ArcGIS Pro or QGIS. Becky has a great workshop in QGIS that's linked within that first link that I sent you. You'll find it on there. And all of the intro to ArcGIS Online classes that we have on campus are really great. I've heard great things. So from the small suite of ArcGIS Online tools, we can summarize our data. We can find locations if we're working with watersheds and things like that. analyze patterns. Like we can calculate density if we have, if we're working with population data or buildings, we can calculate density and hotspots, clusters. We can create boundaries for our data and dissolve them, merge layers. But for today, one of the most common tools that I have seen people use is a spatial join. So we're going to join our features. We are going to choose our target layer. And I will tell you that even though I've been using the software since 2017, I still have to kind of like guess and kind of remember what the target and join layer is. It's not intuitive. Don't feel bad if you get tripped up on things like this. But in general, the target layer represents the features that you are most concerned with looking at, and the join layer is the additional data that you want to combine with the target layer features. So let's say that I'm interested in knowing what towns my campuses are. Like if we had more than 5 for whatever reason, if this was representing not just UMass campuses, but all of the colleges within Massachusetts or the country, right? We are going to identify our target layer as the campuses. And I'm going to choose my join layer to be my zip codes. So there are 2 ways to do a join. There is an attribute relationship, which is when within your attribute tables, you have a field that represents the same thing within both of your data sets. So let's say that within my UMass campuses, let's open up the attribute table. I'll actually show you guys. Right now, my 3 fields are the campus name, latitude, and longitude. That's all that I have in here because this is just a data set that I created on the fly. From public data, you will see a lot more detail, especially when you're getting it from a reputable source like the MassGIS website. So there's the postcode, postcode name or a town name, I'm assuming, and you can find more of the information of the metadata on the actual MassGIS website. But let's say that for whatever reason, my UMass campuses also had their postcode listed, right? I can use an attribute relationship to link those 2 things together by their attributes. So it'll match up all of the postcodes within both data sets that are the same, and it'll link that data together. However, my data doesn't have any of that. So we're going to use a spatial relationship. So that means that it will join the 2 data sets together based off of where they are physically. So we can choose a type of spatial relationship. There's 3 types. The intersects type is used more so for line data sets that intersect other polygons. We can choose within a distance. If I'm saying, okay, what campus is within X amount of miles from this other point data set, like fire stations, for example, or completely within, which is what I'm going to use. So what I'm telling ArcGIS Online is, or what I'm asking it to do, is to show me the zip codes that have UMass campuses completely within them, if that makes sense. Does that make sense to everybody? I hope I explained that right. For our join operations, we have 2 different types. We are joining one-to-one here because I know for a fact that all of the zip codes that I identify, or all of the polygons that I identify, will only have 1 school in them. If for whatever reason we had a ton of points and there were some polygons with more than 1 point in them, that would be a one-to-many relationship. But we're going to choose one-to-one. For multiple matching records, again, this is only valid if you're working with more than 1 point per polygon, let's say. We're not going to worry about the join type, inner join versus left join. That's a little bit more technical, but we are going to name our join. So this is going to be towns with UMass campuses in them, saving it in my folder. And again, as I mentioned last time, these kind of analysis tools do cost ArcGIS credits, ArcGIS Online credits. So we're going to estimate it first to make sure that it's not too expensive. It's telling me that this costs about half a credit, a little bit more than half a credit. I'm okay with spending that. If our data set was really large, it would cost a lot more. But we're going to run that. And then this little status comes up where I can view it, and I can view it in real time as it's completing. For any more advanced analysis, I would recommend using ArcGIS Pro instead of Online. I think that's a little bit of the downfall of ArcGIS Online, is that the analysis bit is it is costly because it costs credits, and it does take quite a while to run because everything is getting uploaded to the server and then coming back down. If this was all local, it would be a lot faster, but it did complete. And I don't know if you guys noticed, the circles of that join did come up as identifying which polygons which polygons are with have a campus within them. So if we turn all of our other layers off, that is what that data set looks like. And I think last time that I did this, I had those flipped, so it was actually showing the polygons. So these kinds of things take a little bit of trial and error, a little bit of experimentation, but hopefully you guys feel like you can display your own data and work with it a little bit within the analysis tools by now. So that's all I have planned for today. We have 15 more minutes left. Thank you all for joining me on this wild journey of my internet troubles within ArcGIS Online. But I will be here for another 15 minutes, and I'm happy to answer any more specific questions about working with your own data within ArcGIS Online. And yeah, thank you again for coming.
Thank you.
Thank you.
Do you have any suggestions on cleaning data before utilizing it in ArcGIS Online?
Yes, let me just